everyone. This is a demo for the final project of the Coursera Advanced Embedded Linux Development Specialization. The project is simple. It's a socket server running on a Raspberry Pi and connected to a camera, and then you can stream different types of data through that server. You can send and receive text, but also you can stream images or actually a sequence of frames through that server by sending a special token that the server understands and then triggers the camera, captures a frame, like how many frames you tell it to capture, and then return it to the caller, to the, in this case, the command line. So if we were to demo that, let's first of all, let's SSH into the Raspberry Pi, and the server is running on port 9000. So let's forward this to make it easy to send commands to the device. And then just a quick check on the kind of version of the kernel running on the Raspberry Pi, and just to make sure that it's actually a Raspberry Pi and everything else. And let's view the messages coming from the server to the system log, just to make sure that everything is going well and the server didn't run into any issues. So as we mentioned, you can come here and then send a like random text to the device, and then netcat Raspberry Pi 4 port 9000, and then wait 1. Awesome. We wrote text to the server before, but then the way it works is that it returns like all the data that you sent previously. If we send hello to, it responds with what you sent in addition to everything else. But the point of this demo is mainly the camera module. That's the special token that we mentioned before, like that string like HDCam, IOC, stream, and then the number of frames 1 for now, to make it easy to save it into a file and then display it. And then boom. And then let's see that test file that we created. Here we go. That like the camera is not very high quality, and it's facing a window, so it's not the brightness like is affecting the camera, but like you see the point. Send a special token, the server processes it, and then returns a frame because we told it to capture only one frame, and then we display it. And then if we check the logs, you see that the server is reading from the camera, open device, initialized the device, and then capturing, reading one frame, returning, and initializing, and everything. This project uses Yocto to build. So a little bit about the development environment. We have a development machine, and then this is where the code lives and all the git commands are run, and then here's the part that you process that token and initialize the camera and everything. We used Video for Linux to kind of API that the kernel provides without needing to use like OpenCV or any other libraries. It's like a facility provided by the kernel, and we use that to capture images and do everything we needed to do. The code is on GitHub if you're interested and you want to take a look. And then we create like a recipe, a Yocto recipe, to read from the code where from the repository where the socket server and the camera module lives, and then bring it into Yocto, build it, and then generate the image that we want on the target. And then we push that to a Linux host, like a build machine that, as you see, like the last build that we made and generating everything. And then we have like custom scripts that fetches the images and the applications from the building machine to the host machine, and then we deploy it into the target not to get into too many details here, but that's the quick overview of the development environment. Um, I hope you enjoyed this demo, and if you have any questions, I think you can post a message to GitHub, and once I see that, I will get back to you. Thank you so much.